Hi everyone, today we're doing lesson 2.4, Solving Linear Systems by Elimination. What we're going to learn in this lesson is first what the definition of additive inverses is. And we want to be able to find the additive inverses of terms in a linear system or a linear equation. We want to be able to use additive inverses to eliminate terms in a system in order to do the last thing, which is to solve a system, i.e. find the POI, using the process of elimination. So these are our learning goals. So let's first talk about what an additive inverse is. So simply put, an additive inverse or additive inverses are terms that are exactly the same but with opposite signs. So in this example I say, for example, 14y and negative 14y are additive inverses. So if I asked you for the additive inverse of negative 2x, you would tell me that the additive inverse is positive 2x, and these two things, because these two things add to 0. If I gave you 5xy, you would tell me the additive inverse is negative 5xy because these two things add to 0. So we're going to use two concepts here. One is a concept of additive inverses, but the other concept is the concept of multipliers. So we talked about how multipliers, if we take an equation, let's say 2x plus 4y equals negative 1, and if we take this equation and if we multiply it by, I don't know, say 3 to get 6x plus 12y equals negative 3, we know these lines are the same. And the reason they're the same or equivalent is because we've multiplied each term by the same amount. So combining these two concepts, we can jump right into the process of elimination to solve a system of equations. So similar to substitution, what we're going to do is label our equations 1 and 2, and we could really easily isolate y in equation 1 and sub it into equation 2 and solve, but that's not the process of elimination. So we're going to do elimination here, and I'll show you how. The first thing I want to do is identify the variable I want to eliminate, and in this case I'm going to choose to eliminate y. I could very easily eliminate x, but it turns out y is a slightly better choice in this situation. Why? Because the first thing I want to do is figure out the lowest common multiple between y and negative 2y. And of course, this is because I want to come up with the additive inverse of y. So I can see pretty clearly that the LCM here is 2, or 2y. And so what I want to do is develop additive inverses using multipliers. So I'm going to take the first equation and I'm going to multiply it by 2, and I'm just going to copy and paste the second equation. Now remember, I have to multiply every term in the line by the same multiplier so that I don't change the line, and then I'm going to copy and paste the second one. And what I can see is that in choosing that multiplier, okay, I've created an additive inverse in my y terms. So now my next step is to add these two equations together. So what I can see is I get 7x plus 0, which I'm not going to write down, equals 42. And something to note here is that in this line, I should have only x, okay, only an x term, because I have successfully eliminated y. 7x equals 42 means that x equals 6. All right, so we know that x equals 6 in this answer, in this system. So what I have to do is sub x equals 6 into either 1 or 2 to solve for y. So I'm going to put it into equation 1. and I'm going to see that my y value is 0. So we're going to write a final statement. The POI, or the solution, is 6, 0, always in order x, y. All right, so in the next one, we can see actually that our system has been jumbled up, and we need to, in order to eliminate, we need to write it in the following format. What we want to do is we want to line up all the x's together, all the y's together, all the equal signs together, and all the constants together. So in this case, I need to rearrange the first line to be 3x minus 2y equals 5. And then the second one is already set up properly. And just a quick note, I know that my system is intersecting because from a previous lesson, I can see that there is no multiplier. There is not a common multiplier between the x and the y terms. So I know that this system has different slopes and therefore it will be intersecting. So it will have a point of intersection. Just a side note, you don't have to know that for elimination. So let's do elimination. So using my rearranged system, I'm going to choose to either eliminate x or y. Let's eliminate x. If I want to eliminate x from this system, I can see that the LCM between 3x and 2x is 6x. So what I want to do is develop additive inverses of 6x in this system. How I'm going to do that is I'm going to take my first equation and I'm going to multiply it by 2. And I'm going to take my second equation and I'm going to multiply it by negative 3 to make one of them a negative term. Now remember, I have to multiply all 3 of the terms in the line by 2. And then I'm going to multiply all 3 of the terms in the second line by negative 3. And then we need to add the system together, or add the 2 lines together. And because my x's, y's, equal signs, and constants are lined up, this should work out nicely. So I get negative 13y equals 26, or y equals negative 2. I'm going to sub y equals negative 2 into one of my other lines. I'll sub it into 1, so 3x minus 2y equals 5. 3x plus 4 equals 5. 3x equals sorry, I made a mistake there. This should be positive 2. And this will be negative 4, so this becomes 9, x equals 3. Okay, and we know that the POI of this system is 3, 2. X always comes before y. Okay. What I would recommend is for you to pause the video and try the independent practice and then look at my answers and come back and check them. for this system, I can probably see on the outset that this has a multiplier of 2. Okay, but before I jump to the fact that these two lines are overlapping, I was asked to solve these. I am going to solve these by substitution, so you can see what happens by substitution. So what I'm going to do is take the first equation and multiply it by -2. And what I'll see is that when I go to add these two together, what ends up happening is I get 0 equals 0. And from a previous lesson, we learned that this has meaning. This is a statement, a mathematical statement that is always true. What that means is that there are infinitely many solutions. And graphically, that means that the system here is overlapping. They are the same line, okay? In fact, if I were to look at this line, I can see that both of them are 8x minus 9y equals 4, or negative 9y equals negative 8x plus 4, y equals 8 over 9x plus 4 over 9. Well, why am I doing that? Because we know that when we have an overlapping system, what I'm supposed to do is give 3 sample answers. And the way I do that is by isolating y, or putting it in the form y equals mx plus b, and then I'm going to choose 3 x values, and I'm going to calculate the associated y values. Because these will be points, 3 points on this pink line, and as we know, both equation 1 and 2 are represented by this pink line. The easiest x value to pick is 0. When I sub in 0, I get 4 over 9. Another easy one is 1. So when x is 1, I just sub it in. And I know that 8 over 9 plus 4 over 9 is 12 over 9. And that reduces to 4 over 3. So that's a second point on this line. So in order to find out 3 sample solutions, I really just need to know how to find 3 points on a line. Let's also sub in 2. So when x is 2, I get 16 over 9 plus 4 over 9, which is 20 over 9. Okay, so we can say 3 sample solutions are 0 4/9, 1 4/3, and 2 20 over 9. All right, so for D, this one is very straightforward, but I would recommend using a calculator. Okay, don't try to do all these calculations in your head. Okay, you're going to want a calculator for this one. Okay, guys, there was a small typo in this question, so can we fix this, please? We're gonna trade the 2 and the 6. This should be 2, and this should be 6. And we're gonna trade the 5 with the 3. This should be 3, and this should be 5. Okay, so on Monday, Kathy buys 2 chicken sandwiches and 6 roast beef sandwiches for a total of $23. The next day, on Tuesday, when she buys 3 roast beef sandwiches and 5 chicken sandwiches, the order costs $27.50. So using this information, find the cost of each type of sandwich. So we are going to let X represent the cost of a chicken sandwich. And we're going to let Y represent the cost of a roast beef sandwich. And what we can do is use her Monday info to write one equation, and we can use her Tuesday info to write a second equation. So on Monday, we had 2x plus 6y, and that costs $23. On Tuesday, we had 3y plus 5x equals $27.50. And we can see that we're going to have to rewrite this system because we want to line up the x's and y's and equal signs and constants. So we've got 5x plus 3y equals $27.50. So I'm going to take 1 and copy and paste it. I'm going to take 2 and multiply that by -2, and this should work out.